each of those equal to 0?
X equals -3/4 and X equals 2.
Good. That was really well done. Really well done. So that's that's the most difficult type. Teachers like to kind of follow up a really hard one with one that's a little easier, a little faster. So here we go. We'll look at x squared minus 13x. What do you see when you look at something like this?
There is not a third term on the side of the like not on the 0 side.
Right. So there's only two terms. They both have an x in it.
Yeah. I think it was something you said on Tuesday that with like sometimes with these where it's like the A equals B equals C equals, it's B equals 0 because
yeah, B can equal 0, but in this problem, the A is 1 and the B goes in front of the x. So you're right though to think that this is not the same as the last one. It's got x and x. That tells you GCF. Two terms. So what goes into both? What factors into both here?
one.
Okay, for the number, yes, but what about for the x's?
Oh, 1x.
Yes. So you can take a 1x out of both. What goes inside parentheses?
X minus 13.
Yes. And then just like the last problem, you set them equal to 0.
So x equals 0 and x equals 13.
Yes. All right. Any questions on that?
No.
Okay. Number three here. This does have it's got an A, a B, and a C. You've got no GCF. It is A equals 1. Problem is there's not two numbers that multiply to 9 but add to -4. The only possibilities here are -1 and 9, 1 and -9, -3 and 3. So those don't work. Okay, which means we got to go down the list here to quadratic formula or completing the square. They both are in play here. So do you have a preference?
I'll complete the square.
Okay, so to do that, first move that 9 over. And then I'll leave the box here. You can tell me what to fill in on this one. Whenever you get up there, I don't mean to rush you, but that is kind of the next thing here.
+4.
It is +4. What goes in parentheses down here?
X minus 2 squared.
Good. On the right, it's 13. Okay, we're almost there. How do you undo this to get to X? What's the next thing here?
Gotta find the square root of both.
Good. On the right, it's plus or minus the square root of 13, but it does not have a known square root, so we just leave it as is. What's the last thing to do here?
The 2 to the other side to get X alone.
There you go. Really good. Do you feel like you can do those types of problems on your own for the exam?
Yeah, they're
Okay.
pretty straightforward.
Yes. You basically did those on your own with a little nudge, which is great. You know, you've come a long way to be able to do some of these without much input from me. All right, on to number 2. I guess it's the second number 2. Yeah, second number 2. Given f of x equals x squared plus 2x minus 8, write the equation in vertex form. So we're just going to stop right there. That means you have to complete the square. So you did such a nice job of completing the square in the last problem. Most students actually would have used quadratic formula on that, but I actually think you made the right choice by completing the square. It's a little faster. Will you do the same thing here and complete the square for us?
Sure. I get +4.
Okay. How did you get +4? Because the last problem you said +4 and it was a different number in there.
Yeah. I got
Like
or
what did you? Yeah. What?
for the above thing or because for
Well, for this one, I mean, I'm interested in this one. Like you do something to this 2. And the one
X
yeah, go ahead.
X plus 2.
Okay, the previous one though, didn't you cut it in half and then square?
Oh, wait.
So you have to divide by 2.
I forgot the key step.
Yeah, now there's like 2 types of problems here where it actually just works out, you know, kind of you can do it incorrectly and it still works, but yeah, by now we got to get it. So in your problem, you have to cut that 2 in half.
Yeah.
So what is that?
That's 1.
X plus 1 squared. What goes up here?
+1.
Plus 1, yeah. And when you add 1 both sides, okay, you get 9 on the right. Now the difference here when you complete the square is you don't keep solving it. You will for something else, but not for this. Okay, so you end up moving the 9 back. So you subtract 9 from both sides, and your function is now x plus 1 squared minus 9. Is that okay?
Yeah.
All right, now from here we can do a bunch of stuff. Okay, we can figure out which way does it open, vertex, axis symmetry, all the stuff basically they want from here. Okay, so the vertex, actually the way that it opens is based on the A value. The A value is right there in front of the parentheses. So A is 1 and it's greater than 0, and that means it opens up. Are you able to hear me?
Yeah.
Okay, I'm sorry. I moved some cables here. I just didn't want to think I was like unmuted for the rest of the lesson or something. You can hear me.
Yeah.
Okay, so the A is greater than 1, it opens up. That's the first thing. Check, we got that. Vertex, I'm going to write the general form of vertex below here. The vertex is h comma k. All right, so your vertex in this problem, your h is like opposite or inverse, and then k is the actual value there. Can you give me the values of h and k?
Yeah. -1 and -9.
Yes. Okay, that's great. Axis of symmetry. It's the x value of the vertex. It's an equation. So x equals -1.
Yeah.
Okay, the y-intercept and some of the other stuff we haven't really addressed, but some of the stuff is easier to find, comes better from the original. So the y-intercept is probably easier to find from the original because the y-intercept is when x equals 0. I'm sorry, it's when x equals 0 for the y-intercept. And that means you're putting 0 in for x. So it just ends up being that last number there. Sometimes they want it as an ordered pair, so you can write 0 minus 8. Just depends on what your teacher wants. All right, and then the next thing is the min or max. So the min or max comes from the vertex. The min or the max is always the y value of the vertex. And it depends whether it opens up or down. So since this opens up, might even be good to draw something like that. Is the -9 a min or a max there at the bottom?
It's a minimum.
It's a min, yeah. And that means there's no work on that. You just have to know it, study it from there. And then the last thing are the zeros. The zeros really come from either the original, if you can factor, either this original up here on the left that you can factor, or kind of this completing the square step. Since we already did the completing the square, I would recommend doing the zeros from here and setting the solving for x basically.
Okay.
So will you do that for us, please? It does work out kind of nice.
All right. I got 8.
There should be two answers because you're taking the square root of both sides. And when you take the square root, it's plus or minus.
Oh yeah.
So just a small thing, but you know, this. And then it's like case 1 to case 2, x plus 1 equals 3, x plus 1 equals minus 3.
Yeah, so I get x minus 4 and x plus 2.
Yes, yes.
X
Okay,
equals 2.
so that's good. Those are the two x-intercepts. Fantastic. 3 is really, really similar to 2. And I would recommend that we not do 3 just because of the time that we have, unless you say, hey, I really want to do 3.
Yeah, we can skip 3.
Okay. So moving on to 4, or this first 4. The next problem here asks for the vertex and the axis of symmetry. You might think we should complete the square. We should complete the square. Well, this one's a little bit tougher to do that. And if you recall, you can also use formulas for that. You can use x equals minus b over 2a. And I would recommend we do that in this problem rather than completing the square. All right, so is what's a, what's b, what's c?
A is 4, B is 16, and C is 3.
Okay. So this is minus 16 over 2 times 4. Could you go ahead and simplify that for us, please?
Minus 2.
It is minus 2, but that's only the x coordinate of the vertex. The vertex is, you know, x, y, h, k, but it's 2 numbers. How do you get the y value of the vertex?
You put it back into the equation, I think.
Yes, yes. The y value you get from taking that number. When you substitute, best to substitute in parentheses.
Uh, 35.
I think we got some sign errors here. Minus 2 squared is 4. 4 times 4 is 16. And then minus 32 plus 3. Take another look at that and see if
Oh, yeah. I got minus 13.
Yes, that is correct. Okay. So you've got to present your answer as an ordered pair. You know, you might even throw in the word vertex at -2, -13. Okay, now the axis of symmetry. Which value are we choosing for the axis of symmetry in the vertex, from the vertex? We did this in the previous problem, if you want to look back at your notes.
It would be -2.
Yes, x equals -2. It is an equation. You got to write it as an equation.
Yeah.
All right. Next problem here, number 5. When I looked at this problem here, I guess I want you to think through whether you're going to be given the equation at the bottom for a falling object, or if you will have to memorize this.
We're probably going to be given the equation.
Okay. So when we were doing these problems, you had to read through it and figure out the values of V and H. Would you take a look at this and tell me the values of V and H if you can?
H is 3, V is 64.
Sorry, yeah, H is 3, V is 64, like you said there, plus 3. Okay. And when we were talking about these problems, there's kind of 3 places that they might have you answer. Typically it's 2 and 3, like the max, the vertex, or where it comes, come back to the ground. This problem actually asks for multiple things. You know, one of the reasons we're not getting very far in this is because every question's asking for multiple things here. So the maximum height the ball will reach is the vertex. So just like the last problem, we should use formulas to do that. Minus b over 2a. That'll give you the x coordinate of the vertex. Will you calculate that for us, please?
Sure. I got 2.
Yes. So we got minus 64 over 2 times minus 16, or 2. But that's only when it occurs. Where it occurs, or what the max is by putting that value back into the original. So last time you did this, just there were a couple of sign errors. So really just take your time. Sometimes it's good to redo the calculation twice.
195.
All right. Small, it's just again, small kind of thing. I'm not quite sure. 2 squared is 4. 4 times minus 16 is minus 64. Not sure if you're entering all this in at once. You can. You can go to that Desmo Scientific and put it all in at one time. It's not that large. It's 67. Where do you think your mistake is coming from, or what do you think is happening?
I think it was I multiplied negative 16 by 4. I thought it was positive 64.
Okay, yeah, and that would change it significantly. And because we don't see it, we don't. Yeah, my graph is not to scale. There's no way to know whether you're right or wrong. I mean, if you got a negative height, maybe, but that's why I suggest doing the calculation twice. But you could always say, well, I'll just make the same mistake twice. You just gotta, do your
I'll
best.
just use the calculator the entire time.
I like that
just
strategy.
to make sure.
Yes, I like that strategy. Okay, that is the maximum height. We really should give it units. The units are feet. But wait, there's more. We are now going to figure out when will the ball hit the ground. That's over here at 3. When will the ball hit the ground? Typically, in these types of problems, you're going to use quadratic formula for it. They don't factor unless they choose really nice numbers. So you're setting this equal to 0, and quadratic formula, A equals minus 16, B equals 64, C equals 3. You're going to get 2 answers with the quadratic formula. So you're looking for the one that's positive in this case. So why don't you calculate the B squared minus 4AC for us and use your own words of wisdom here. Go and use the calculator if you can.
I got 4,288.
Good, really good. Yeah. All right. So the reason we do that first is the rest of it here for solving for the variable is not too bad. It's minus b plus or minus the square root of that number all over 2 times a. So minus 64 plus minus the square root of 4,288 all over negative 32. If you're going to use the Desmo Scientific, you can just enter it the way you see it. 1 positive, 1 negative. Go ahead and see what you come up with there.
All right. Okay, I had a slight problem with the calculator, but just
That's okay. Do you have some answers or a answer for me? An answer?
answer. It's still not a pretty number. What's
It's not.
like a bunch?
It's going to be a number with a bunch of decimals. That's
Yeah.
to be expected here. Why don't you throw out, that's kind of the whole, like sometimes in life it's like, who's going to be the first person on the dance floor at the the wedding? And right now it's not you. You're like, I'm not going to run out there, but someday maybe you will be that person that's like, I can't wait to be the first one out there. You just got to try, throw something out there, see what sticks.
Okay, so I got negative 0.05
Okay,
and
good.
4.05.
And that's the correct one. The analogy to the dance floor, everyone who isn't on the dance floor wishes they were on the dance floor. They're just all afraid to go first. All right, good job on that. We got we're gonna head over, we're gonna flip over to the other side. We should have enough time to do a lot of 6. All right, given f of x equals x squared minus 2x minus 3, find the following. I would like you to do the completing the square on this, because I think that is the best path for you here, just as a reminder. So would you kindly complete the square for this one, please?
Sure. I got +1 for the
Okay, plus
uh,
1, plus 1.
blank.
What goes in parentheses down here?
X minus 1 squared.
Good. And then you're going to move this 4 back for that. So x minus 1 squared minus 4, bring down the f of x. All right, any extra thoughts on that? That's really good to be able to do. Usually, sorry, didn't mean to interrupt you. But any thoughts on that or anything else?
No.
So you learn this the more you take classes, but I can help you shortcut it. When a teacher tells you the first thing, they really want you to do it that way. They're like, we really recommend this. Could you please do it this way? Typically. All right, now we're going to graph it next. 5 good points, 5 good points. So your table here, 5 good points. It's always best to start with the vertex. What is the vertex of this thing?
-1 and -4.
The one inside parentheses is always kind of the opposite inverse of what you think it should be.
Oh yeah. So 1 and -4.
Good. And from here, you always choose 2 smaller and 2 larger, but you're going to also take advantage of some symmetries. So you don't have to calculate all of them. You just got to calculate some. Usually I say go to the positive ones, but 0 is a pretty tough one to give up. I'd recommend putting 0, and probably best to go back to the original. So could you calculate that for us, please?
-3.
It is -3. And by symmetry, this other point is also -3. So now you can either put in -1 or 3 into the original. -1 or 3, your choice. And you can go into the original or the vertex form down here, whichever one you like. They both work. They both give the same result. Maybe one stands out to you.
-0.
Yeah. And then the other one is also 0. All right, so once you have your 5 good points, have you asked your teacher what a bad point would be?
One that's not on like a 0.5 or
Yeah, I mean, those are
0.75.
yeah, I don't know, sometimes it's like good and bad. You're just like, what's so bad about it? The idea is to make it as easy as possible on yourself when you're doing this. So 1, -4. Usually start your vertex. 2, -3 by symmetry, the other one. And then you got your intercepts, which is nice. So then you make a nice smooth curve here. Make it look like it was, recent graphics, not something from the 80s. Any, what do you think of that? Do you feel like you'll be able to do that on your own?
Yeah.
Yeah, I do too. I think you're doing real well on this. All right, let's jump down to C. I know it says vertex form and factor form. We'll come back to that if we have time here. So you kind of already answered a lot of this. The vertex is at 1, -4. Is it a min or a max?
Minimum.
It is a min. The domain is always all real numbers. The range depends on whether it opens up or down. Since this one opens up, you would write y greater than or equal to the y value of the vertex, which is -4. If it opened down, it would be y less than or equal to some number for the range. How about the axis of symmetry?
1.
X equals 1, good. I don't know that we've talked much about it. X-intercepts, do you remember? I'm sorry, concave up or concave down. Do you remember the difference between that?
Concave up is it can hold water.
Yes. Yes, you think of that. All right, yep, I'll pour some water in there. And the other one is obviously doesn't work as well. So this one is concave up. And then the y-intercept we actually found already from our table. You have it here, 0, -3. If you didn't have it, you would have to put 0 in for x. The x-intercepts you would get from either factoring, completing the square, but you actually already have them from the graph, which is really nice. I don't know if you could expect to get that every time, but it does seem to work here on this one. All right, well, we are unfortunately out of time for today. It goes quick.